AI watched the world through the eyes of a baby, but instead of just recording, it started to learn, linking words to the objects it saw, just like a human child. This isn't science fiction, it is a real experiment, and it reveals something profound about how we, but also how AI learns to perceive the world. So in this video we are diving into this groundbreaking study where AI learns like a baby and also some lessons that we gather along the way. So let's go. Hi there, I'm Yvette, a neuroscientist and an author of several neuroscience studies. On this channel I break down how the brain works, decode its mysteries, and how we can apply this knowledge to our lives. So if this is something that you're curious about, I would just suggest to hit the subscribe button. For decades, scientists have debated the deceptively simple question, and that is, how do babies learn their first words? This might seem obvious at first, because they hear words like ball while they're looking at a ball and they connect the dots. But that's just the surface, because underneath it's a real mystery. The scene is chaotic, cluttered. A baby hears ball while seeing a dozen things, like a couch, dog, and a sibling yelling in the background. So how do they know which object this word is referring to? And in the field, this is known as the problem of reference. And it's been a core puzzle in cognitive science and philosophy. Some researchers believe that babies rely on innate mental structures. And this is hardwired knowledge, like a grammar instinct or built-in categories. Think about it, why is it only humans who have developed language on this earth? Others argue that learning happens through simple association, where the brain tracks patterns over time, basically by training the algorithm. And here's the wild part, we still do not know who is right. Even as a neuroscientist, I've had to come to terms with the fact that the fundamentals of how language learning begins are still up for debate. And that's why this new study is such a big deal, because they address this question head on in a pretty smart way. And what I found even cooler is that instead of using artificial lab setups or massive unrealistic training data sets, like most AI research, these scientists took a radically different approach. They captured real-world audio and video from a single child, 61 hours of it to be precise. 61 hours of what the baby heard and saw over the span of 1.5 years. Then they trained an AI model on this messy, incomplete, but real dataset to see if it could figure out which words refer to which object. And doing this just by watching and listening. No labels, no supervision, and no grammar rules baked in. Simply just raw experience. The result? The AI, called CVCL, or how I'd like to call him Cavill with the silent C, actually did learn. It picked up real-world object associations, and it aligned visual and language concepts. And to top it all off, it even recognized images that it hadn't seen in the dataset. In other words, this model broke into language understanding using only the kind of input that the baby gets. And that's why this experiment is so important, because it shows that maybe, just maybe, the mystery of word learning is not as mysterious as we've thought it was. Maybe we don't need a full mental dictionary built in. Maybe patterns, experience, and the right kind of learning are enough to learn a language. But let's dive deeper in the experimental setup and results in the next segments. So, how do you teach an AI to learn like a baby? Well, you start by giving it the baby's worldview, literally. Over the course of 19 months, researchers recorded 61 hours of video recorded from a head-mounted camera worn by a single child, starting at 6 months old and ending at 25 months. This resulted in a massive archive of first-person baby footage, 600,000 video frames paired with 37,500 lines of transcribed speech from parents or caregivers. The dataset, called SACAM-S, captured moments like "here's your spoon" or "where's the ball," while the baby was seeing these objects or holding them, or even someone else interacting with them. The next step was to train an AI model on this data. The model is called CVCL, which stands for Child's View for Contrastive Learning. It is a type of neural network which is divided into two parts. One that processes images and the other one that processes language. You can think of them as translators. One takes a video frame and turns it into a mathematical representation, the color, texture, and shapes, and the other one does the same with spoken words, turning them into a representation of meaning, sound, and structure. The model then learns to push together the representations of things that happened at the same time and push apart the ones that didn't. This is called a contrastive learning objective. And it's kinda like training the model to guess which words go with which scenes, without ever being told explicitly. Over time, the word-image pairs start to cluster in the model's mind. The word car becomes mathematically closer to images of cars. Crib gets close to cribs. And over time, a kind of conceptual space starts to form, one that is grounded in the baby's real experience. After being trained on just 61 hours of real-life baby footage, a fraction of what a child actually experiences, Cavell was tested to see if it had learned anything useful. In one test, the model was given a word, like car or spoon, and it was asked to choose the correct image from a set of 4. This is similar to how researchers test young children's vocabulary, like show me the ball and you see where the child looks or points. Cavell got about 62% accuracy, which is far above chance. That might not sound impressive at first, but here's the thing. At the time, it performed nearly as well as Clip, OpenAI's massive trained algorithm, trained on 400 million image text pairs scrapped from the internet. And Cavell did this with no labels, no internet, and no curated datasets. Just one baby's daily life. The model learned the meaning of common words, such as words like ball, crib, car, and floor. But it also struggled with more variable concepts, such as hand or toy. Why? Because those concepts appeared in many different forms, from different angles and contexts. The more visually consistent a concept was, like a crib always being rectangular or a car always having 4 wheels, the better the model did. And then it got even more interesting. Cavell was tested on new, clean images that it had never seen before. Think of objects photographed on white backgrounds. And it still performed above chance, which meant that Cavell could generalize. It wasn't just memorizing, it had built a flexible concept space. In a way, it was learning the essence of what a car or what makes a spoon. And the coolest part of the study is when the researchers mapped out the model's internal concept space. The words and images clustered together in meaningful ways, showing that the visual and linguistic systems had aligned. Words which were similar in meaning clustered together, for example like road and car. Or actually this formation over here where ground, sand, foot and hand are clustering together, which makes total sense if you think of what kids do in playgrounds. And here, a ball and a cat cluster together. Ooh, what are you saying here, Cavell? It's as if the model was starting to build a conceptual map, not just linking words to images, but actually organizing ideas. This experiment isn't just about AI. It is a reminder that learning, real grounded learning, doesn't always need rules, labels, or instructions. Sometimes patterns and presence are enough. Cavell didn't need a predefined dictionary or a built-in understanding of language. It just needed exposure to see and hear enough of the world and to start connecting the dots. And this, I believe, is a powerful message, not just for AI researchers, but for all of us. Because it means that intelligence doesn't start by knowing, but by noticing. And if a machine can begin to understand the world from the messy, chaotic perspective of a single child, then maybe what we think about learning in kids, in adults, basically in ourselves, needs to expand. As a neuroscientist, this reminds me that the brain doesn't always need blueprints. Sometimes all it needs is just input. And as someone who has spent years trying to understand the brain, actually it is quite humbling to realize that we are still learning the basics. So if you're curious about how the brain and the machines are evolving side by side, you're in the right place. And if you have ever wondered how the brain truly stacks up against AI, well, that's exactly where this video will take you next. And with this, thanks for watching and see you in the next one. Ciao!